much. This is the last talk before lunch, I think, so I hope you can still bear with me. But my colleague Margit set the stage for me really nicely, so she made my job a lot easier. Thank you, Margit. So I will just try to explain to you how we do this regional climate modeling Margit mentioned in her talk. So then I can skip many parts, basically. So yeah, basically we do downscaling. I mean, in regional climate modeling, the disadvantage is you always depend on a global climate model. So in this case, we downscale the NORCE, Norwegian Earth System models global data. But the advantage of this, of regional climate modeling, is you can put your domain wherever you like and you can make it whatever the size you like. So in this case, we put it on Southern Africa. Sorry. Oh, what happened? Yeah. This looks random a bit. Yeah. Yeah, sorry. Yeah. So we put it on Southern Africa because that's the area we are interested in. And when we downscale it, we get a horizontal resolution of 12 kilometers, which is very good because we want to interpret our climate data regionally and locally, because this is very important for early humans and their settlement patterns and their migration patterns. So another advantage of regional climate models is you can run them as many times as you like, because they are not computationally that expensive compared to the global climate models, because you run them on limited areas, and you can include or exclude any climatic feature you like. Be it coastline, for example, the exposed land when the sea level changes and when the coastline moves, or be it sea surface temperatures. You can play with sea surface temperatures, you can play with other things, and you can see how these climatic features affect your results. That's the advantage of regional climate models. And in our case, as you see, within the time period we are interested in, sea level was quite different from each other. As you see here, for example, at 93 sea level, 93,000 years before present, sea level was like 54 meters before the present level, the modern sea level, and at 63 it was 100 meters below sea level, but 82 it wasn't that low. That's why here you can see that exposed land resulting from this sea level drop was not that wide. But compared to this one, at 70,000 years before present, there was a big chunk of extra land before here in front of Blombos Cave, and that was not a coastal site as it is before. So this is very important from a climatic point of view, and you will see that. And that's, of course, not the only climatic features that was different through all this time. This is the precession cycle, as you see here, and this shows the incoming solar radiation. When we are high up, the insolation is higher, so that affects the climate, especially in the interior regions of Southern Africa, and it makes the region wetter, basically. So you can all separate them with the regional climate model and see how their individual effects were. So, as I said, you can, for example, with the regional model, check just the effect of the coastline shift. Basically, you freeze the time, you use the same data from 70,000 years before present from the global climate model. You just set everything the same, only to change the coastline. And then when you shift the coastline here, as you see, this is the modern coastline, and when you shift the coastline to the south, as it happened 70,000 years ago, there was an extra chunk of land here which affect the climate of the region profoundly. As you see in these results, this is not, of course, completely unexpected, but it's still good to see in the results and have a robust conclusion. So daily maximums were higher if the coastline moved to the south, because the continental was much more, the climate was much more continental when this happened. Daily maximum temperatures were higher, minimums were lower, and of course the precipitation was lower as well, because basically less moisture came to our sites, because basically the ocean was further away from the Blombos Cave and from all these archaeological sites on today's southern African coast. Of course, this is not the only application you can go for. There is also the real-world application. You don't have to freeze the time, so you can just analyze all the climate change from 93 to 63, as we did it here. As you see, this is, for example, the change from 93 to 82,000 years before present. And as you see here, there is not much coastal change between these two particular periods, but the biggest change is the change in the insolation arising from the change in precession cycle. And as you see, there is a big drop in precipitation from 92 to 82, 93 to 82, because 82 is much lower in the precession cycle, and there is less insolation in the interior parts of the region. But as you see on the coast, this region is not really affected from this precessional cycle change, the insolation change, and the signal here in precipitation is quite heterogeneous, as we don't have much change in the coastline as well. But yeah, I think this was shown by Margit already, and this right-hand side figures show the changes when we include the coastline change in the model, and this left-hand side figures show the changes when we exclude coastline changes and if we use only the modern coastline. And as you see, if you just pay attention here, these two, on the left-hand side, when you exclude the coastline change from your analysis, then you don't have any signal actually on the coast, but still in the interior, because of the precessional change, you get the increase in precipitation, but nothing actually on the coast. But if you include the coastal change, then you still get the change from the insolation change, precessional change, but you get this significant reduction in precipitation, because the coastline basically shifted south. This is very, very interesting to see, because again, this is the advantage of the regional climate modeling, as I said at the beginning. You can see the same changes in other climate indices, as you see here. If you don't include the coastline change, for example, in the annual number of precipitation days, you actually get an increase on Blombos Cave area from 82 to 70. But if you include the coastline change, then you get a quite different, the opposite cycle. You get less precipitation and less number of days with precipitation. So this is like actually the take-home message of my presentation. As you see here in one of my last slides, as you see, this is the Blombos Cave. This is an interior area. This is called the Karoo area in southern Africa. So this is a bit looks a bit complicated, but still worth trying to understand. Don't worry, one of the last slides, so it's ending. So here, as you see the changes in all the climate indices we analyzed through time. So this is for the Karoo, for the interior region, and this is for Lombos Cave, for the coastal region. And as you see, the climate change signal, if you just focus on these, for example, number of rainy days is quite different. As you see here, this one, the changes in Karoo, just very closely resembles the change in insolation arising from the change in the precession cycle. This 93 is coming down to 82 and going up again to 70 and coming down a bit again at 63. So looks like the changes here is completely separated from the coast, but on the coast, that's a different story. This is also very close to the regions where insolation is important, precessional cycle change, but then we don't see the same signal here. As you see, but by the way, these solid bars show the climate indices when the coastline is included in our modeling. But the hollow bars show the changes when the coastline is excluded. So when the coastline is excluded, as you see in the Lombos Cave, there is not much signal. But when you include that, it's just going down because as in the 63,000 years before present, the coastline is really away from the modern coast. So we are going just down here very strongly, but we don't see such a change in the interior region, and that change in the interior region is just resembling the change in insolation. So as future work, we will do more downscaling, maybe vegetation modeling also using these WRF results, and also we will analyze the effect of SSTs, because if you put this big chunk of land here, maybe the SSTs are not so important anymore because the sea is quite far away then. So we will, again, using our regional climate model, this time play with SSTs and see their influence. Thank you very much.